Hello, friends. Welcome back and thank you for tuning in. In this episode, we want continue looking at relative motion. If you have checked my other video on relative motion, in the other case, I talked about bodies moving in opposite direction. And so in this clip, we want to look at two bodies moving in the same direction. How do you handle it? And to take us through this is this question that we have here that we want to look at. And it reads, Kisumu and Nakuru are two towns 320 kilometers apart. A bus left Kisumu at 8 a.m., traveling at 60 kilometers per hour for Nakuru. After 40 minutes, a saloon car left Kisumu, traveling in the same direction as the bus at speed of 80 kilometers per hour. Then the first question is, how far from Nakuru did the saloon car catch up with the bus? Then the second part of the same question is, at what time did it catch up with the bus? That is, at what time did the car catch up with the bus? Let's start with this first part. Now, as I earlier advised in the previous clip, now what you need to do is just to draw a sketch to represent what you have. Like in this case, we have the bus and the car leaving Kisumu for Nairobi, though at different times. So the bus moves at 60 kilometers per hour, and later the car moves at 80 kilometers per hour towards the same direction. But the bus starts earlier. So travels for 40 minutes. It's begun at 8, then travels for 40 minutes before the car starts. So by 8:40, so what I want us to visualize in our diagram is that by 8:40, the bus has a head start, what I call a head start distance, which we need to calculate. And we know that distance is equal to speed times time. Speed times time. So the distance that the bus has covered in 40 minutes is actually its speed, which is 60 kilometers per hour, multiplied by 40 minutes. But we now have to convert the 40 minutes into hours by dividing by 60, so that we get now the time, the distance, sorry. So in this case, you can see it's 40 kilometers. So before the car starts, the bus has a head start of 40 kilometers, and you can indicate here. So by 8:40, the bus has already covered 40 kilometers. Now, the bus continues to move as the car starts moving before it catches up with it. So what I would say is, at one point, that is after 8:40, the bus will catch up with the car will catch up with the bus. So we'll say, let the distance covered by the bus, that is after 8:40, before it is caught up with before it is caught up with be, say, x. That is, you come to our diagram here. So assuming that this is the catch-up point, let me show by diagram, catch-up point. So we are saying that after 840, because the bus continued to move, so it was caught up with after x kilometers. Okay, so let that distance be x kilometers. Now what we want to do is to get the time that the bus will move before it is caught up with, and also the time that the car will move for it to catch up with the bus. So in this case, time taken by bus will be distance over speed, and the distance that is to be covered is x, as I indicated there, over the speed of the bus, which is 60. Now, time taken by car to catch up with the bus will be the distance. Now, the distance that the car needs to cover is 40, the one that had been covered, plus x. So it will be the distance x plus 40 over 80. Now, remember they will be at the meeting point or the catch-up point together. So, and the time taken by the bus in this distance x is the same as the time that the car takes from the starting point, which is Kisumu, up to the catch-up point. So what do? We form an equation. So these two times are equal. So in this case, we'll have x over 60 is equal to x plus 40 over 80. When you do your cross multiplication, you'll have your 80x is equal to 60x plus 2,400. Now when you do your calculation, you'll have your 20x is equal to 2,400. Now our x is 120 when you divide both sides by 20. So that means what we have here, we've now found the value of x is 120. You can come and indicate. Now the question was asking how far from Nakuru did the Salon car catch up with the bus. So remember Nakuru is this other end. So you can see the catch-up point is 40 plus 120. That is from Kisumu. Okay. So we can say total distance from Kisumu is 120 plus 40, which gives us 160 kilometers. That is up to the catch-up point. So the remaining distance is the distance between the catch-up point and Nakuru. And how do we get it? So distance from Nakuru will be 320, which is the whole distance, minus the distance that is so far covered from Kisumu, so minus 160. And the answer here becomes 160 kilometers. This is the answer required there. Now let's look at part 2. At what time did it catch up with the bus? At what time did the car catch up with the bus? So we've seen, in this case, we know we need the time. So the time for catching up Remember, time for catching up is different from the time at which the catch up took place. So time is duration. What is being asked for here is now distance over speed. Now what is the distance? Is now you can see 40 plus 120, which we had calculated earlier, which is 160 over 160 over 80, which gives you 2 hours. Okay, it gives you 2 hours. Now, therefore, time that is the time that the car takes is 2 hours. So time of catching up you add the 2 hours to the time that the car started moving. So we'll have 2 that, and then you can see it is 10:40 a.m. So this is the answer that is required in this question. Thank you so much. If you have any question, feel free to comment. Please subscribe if you haven't, and share with your friends, and also press that bell button so that when I upload a new video, you'll be notified. Thank you so much for your audience once again. Bye bye, and always take care.